A newborn foal stands on its own legs within an hour of being born. A baby chimpanzee can grip its mother's fur tightly enough to ride on her back almost from birth. A human baby can't even lift its own head. For more than 60 years, scientists thought they knew exactly why. Today, that explanation is being challenged. The classic explanation is called the Obstetric Dilemma, first proposed by anthropologist Sherwood Washburn in a 1960 paper in Scientific American. The idea goes like this. When our ancestors evolved to walk upright, natural selection narrowed the pelvis to make bipedal walking efficient. At the same time, brains were getting dramatically bigger, and bigger brains meant bigger skulls. Those two pressures collided directly at the birth canal. According to Washburn's theory, the only way evolution could resolve that collision was to kick babies out earlier, before their skulls grew too large to fit, which is exactly why human infants are born so much less developed than other primates. Some researchers even nicknamed the first 3 months after birth the fourth trimester, treating early infancy as if it were really a continuation of pregnancy happening outside the womb because the baby simply wasn't finished yet. For decades, this was the accepted answer, appearing in textbooks, magazine articles, and even best-selling parenting books. But it turns out to rest on an assumption that, when researchers actually tested it, didn't hold up as cleanly as everyone thought. Anthropologist Holly Dunsworth, examining the theory closely, pointed out something the obstetric dilemma requires, but never quite proves: that human pregnancy is unusually short compared to what our body size and brain size would otherwise predict. If that were true, babies really would be arriving early. But when she compared actual human gestation length to other apes, human pregnancy turned out to be only slightly longer than a chimpanzee's, not dramatically shorter than some hypothetical uninterrupted timeline. Human newborns are born with about 30% of their eventual adult brain mass. Chimpanzees are born with closer to 40%. Using that gap, some researchers had calculated that human pregnancy should last around 18 months if the pelvis weren't cutting it short. But Dunsworth argued that calculation assumes chimpanzees represent some kind of ideal, default primate gestation length, when in reality, other primates, like certain capuchin monkeys, are born with even higher relative brain development than chimps. There's no clear reason to treat any one species as the baseline everyone else deviates from. If that's true, then everything you've probably heard about why babies are born helpless might be backwards. In place of the pelvis is bottleneck story, Dunsworth proposed something called the energetics of gestation and growth hypothesis, or EGG. Her argument is that the real limiting factor isn't the width of the birth canal at all, but the sheer metabolic cost of pregnancy itself. By the final weeks of pregnancy, a woman's energy expenditure can run at roughly twice her normal resting metabolic rate, an extraordinary, sustained physiological demand. Under this model, human gestation doesn't end early because of a pelvis running out of room. It ends when a mother's body simply can't keep sustaining that level of metabolic output any longer, regardless of how much room is technically available. This didn't settle the argument, it restarted it. A wave of researchers pushed back directly, publishing a paper explicitly titled "There is an Obstetrical Dilemma," arguing Dunsworth's critique overcorrected, and that the tight fit between fetal head size and the human pelvis is real, measurable, and still an important part of the story, even if the old "babies are born too early" framing oversimplified things. Other researchers have gone even further back in time, analyzing pelvic remains from Australopithecus, a much earlier hominin ancestor, and found evidence that even these smaller-brained relatives already had a tight fetal pelvic fit, forcing genuinely helpless newborns long before brains reached anything close to modern human size. If that holds up, it means the helplessness of human infants isn't a side effect that appeared alongside big brains. It may have been baked into the hominin body plan millions of years earlier for entirely different reasons that had nothing to do with intelligence at all. Whatever the exact mechanical cause turns out to be, there's a genuinely fascinating twist buried in why this helplessness might have stuck around evolutionarily rather than getting selected out. In 2016, cognitive scientists Stephen Piantadosi and Celeste Kidd at the University of Rochester proposed that helpless babies and intelligent parents may have been locked in a feedback loop for millions of years. A baby that can't move, can't speak, and can only communicate through wordless cries forces its parents to develop increasingly sophisticated skills just to interpret what it needs. Hunger, pain, discomfort, fear, all compressed into the same basic cry. Parents who got better shudder at that interpretation, raised healthier children. And smarter parents, the theory suggests, may have then produced babies with even larger brains and even longer periods of helplessness, which demanded even more interpretive skill from the next generation of parents, around and around. Generation after generation, the most helpless creature on Earth may have forced the smartest species on Earth to exist. So the honest answer to why human babies are so helpless isn't a single settled fact. It's a genuine, ongoing argument between researchers over pelvises, metabolism, and fossils, layered on top of a separate, fascinating theory, suggesting that helplessness itself may have helped build human intelligence, rather than simply being a cost of it. What is settled is the comparison that started this whole conversation. A foal stands within the hour. A chimpanzee clings from birth. A human baby lies there, completely dependent, unable to do anything at all except cry. Maybe helplessness wasn't evolution's mistake. Maybe it was humanity's greatest advantage.